On the 24th of November, 1944, in Easley Field, Saipan, within the Mariana Islands, Lieutenant Colonel Robert K. Morgan guided the engines of his B-29 Superfortress, named Dauntless Doy. He was at the forefront of 110 aircraft belonging to the 73rd Bomb Wing, setting a course for Tokyo. The instruments arrayed before him presented a stark reality that the Japanese High Command seemed unwilling to acknowledge. The gauges indicating the boost pressure from the superchargers climbed with unwavering consistency, allowing the aircraft to maintain sea-level engine performance at altitudes where enemy fighter planes would be gasping for oxygen. Today, these magnificent silver machines would showcase a technological edge that Japan simply could not overcome. Concealed within each of the massive R-3350 engines were twin General Electric turbo superchargers, mechanisms that would ultimately prove more critical than any conventional weapon. These ingenious devices harnessed the energy of exhaust gases to compress the incoming air, enabling the engines to sustain an impressive 2,200 horsepower even at altitudes nearing 32,000 feet. Japanese fighter aircraft, designed primarily for agility at lower to medium altitudes, struggled to reach such extreme heights. Their engines, lacking effective high-altitude supercharging, experienced a drastic loss of power in the thin atmosphere. This marked the inaugural B-29 assault on Tokyo, launched from the recently secured bases in the Marianas, positions located a mere 1,500 miles from Japan's capital. In contrast to earlier missions that originated from distant bases in China, these bombers now possessed the capability to strike repeatedly and return to safety. The pressurized cabins ensured that the air crews could breathe normally, while Japanese interceptors contended with rudimentary oxygen systems that frequently malfunctioned at extreme altitudes. As Morgan's bomber ascended into the morning sky, accompanied by more than 100 of its brethren, the technological disparity between American and Japanese aviation became glaringly evident. Just 5 months prior, on the 15th of June 1944, the very first strategic bombing mission by a B-29 against Japan had commenced from Chengdu, China. 75 Superfortresses had taken to the air that evening, although only 47 managed to reach their primary objective in Yawata, Kyushu. This mission, while revealing the B-29's considerable potential, also highlighted the significant challenges that lay ahead. 7 aircraft were lost. 1 was shot down over the target, another was destroyed on the ground following an emergency landing, and 5 were lost due to operational mishaps. In total, 57 airmen perished. Nevertheless, even this costly initial foray underscored the inadequacy of Japanese defenses against high-altitude bombers. Japanese radar operators stationed on Kyushu detected the approaching formations. Air raid sirens blared across Yawata. Pilots of the Imperial Army's 4th Sentai scrambled their twin-engine Kawasaki Kai-45 Toryu fighter planes, climbing aggressively towards the bombers that were flying at altitudes ranging between 8,000 and 21,000 feet. Even at these comparatively moderate heights, necessitated by the fuel constraints of the long mission from China, Japanese interceptors faced severe difficulties. Their Nakajima Ha-25 engines, each rated at 1,080 horsepower, lacked effective turbo supercharging. Above 20,000 feet, these engines produced roughly 60% of their rated power. Warrant Officer Sadamitsu Kimura managed to close in on one B-29, an aircraft identified as the Limber Dragon, carrying 12 crew members. His attack was successful, sending the Superfortress plummeting in flames with no survivors. However, this solitary victory came at a devastating price. Kimura expended almost all of his ammunition and narrowly returned to his base, his engine dangerously overheating at altitude. Around him, other Japanese pilots fired with desperate intensity at the silver bombers, but the majority of their attacks failed to inflict significant damage. The B-29's defensive weaponry, managed by sophisticated fire control systems, responded with lethal accuracy. Captain Teruhiko Kobayashi of the Imperial Army's 244th Sentai, renowned as one of Japan's most accomplished fighter aces, later documented the profound frustration experienced by his unit in official reports. He noted that American bombers operated at altitudes where Japanese fighters could barely maintain level flight, let alone maneuver effectively for combat. The B-29's speed at these heights, approximately 350 miles per hour, was comparable to what Japanese interceptors could achieve in the thin air above 25,000 feet. Merely reaching bombing altitude consumed excessive fuel for the Japanese fighters, leaving them with reduced ammunition capacity and engines running so hot that catastrophic failure was a constant threat. The key to American aerial superiority resided in a technology that Japan had explored but never successfully deployed. General Electric's turbo supercharger, Type B series, designed for the R-3350 engine, represented a pinnacle of engineering achievement. Each B-29 engine was equipped with 2 of these devices, which utilized hot exhaust gases to spin turbine wheels at speeds exceeding 20,000 revolutions per minute. These turbines drove centrifugal compressors, forcing air into the engine intake manifolds at pressures equivalent to sea-level conditions, even at an altitude of 30,000 feet. The underlying principle was elegantly simple. Waste exhaust energy, normally dissipated into the atmosphere, was instead repurposed to perform useful work by compressing intake air. This enabled the engines to efficiently combust fuel at altitudes where naturally aspirated engines would simply suffocate. Each turbocharger added approximately 150 pounds per engine installation, but delivered performance gains equivalent to doubling the engine's displacement. Without these turbochargers, the B-29 would have been just another heavy bomber, susceptible to interception and incapable of leveraging altitude as a defensive advantage. Japan had experimented with turbo supercharging as early as 1941, with engineers from the Nakajima Aircraft Company examining captured technical documents and acquiring sample units through clandestine channels before America's entry into the war. Japanese engineers recognized the substantial military benefits such technology offered. Yet, despite 3 years of dedicated development, Japan never managed to produce operational turbo-supercharged fighters in significant quantities. The reasons for this failure expose the vast industrial disparity between Japan and the United States. Turbo-superchargers demanded metallurgical expertise far beyond Japan's capabilities. The turbine wheels operated within exhaust temperatures exceeding 1,500 degrees Fahrenheit, while spinning at velocities that generated centrifugal stresses equivalent to thousands of pounds per square inch. Any minute flaw in the metal would result in catastrophic turbine failure. American manufacturers, such as General Electric, possessed the requisite metallurgical knowledge, precision forging equipment, and stringent quality control systems to produce reliable turbines. Japan's industrial base, already strained by wartime demands, could not meet these exacting standards. Lieutenant Fumio Nia, an engineering officer who later evaluated captured B-29 components, documented findings that have since been preserved in Japanese archives. Examining a turbocharger recovered from a downed B-29 in China, Nia was struck by the remarkable precision of American manufacturing. The turbine blades were machined to tolerances measured in thousandths of an inch and balanced so perfectly that the units spun at maximum speed without any discernible vibration. The high-temperature alloys used in the turbine's construction surpassed anything produced by Japanese industry. Even the bearings, designed to function flawlessly in extreme heat while maintaining precise alignment, represented manufacturing capabilities that Japan lacked. Even more impactful was the systematic nature of American turbocharger production. General Electric's plant in Schenectady, New York, manufactured thousands of these units monthly, each conforming to exacting specifications. Production lines incorporated automated testing equipment, verifying the performance of every single unit before installation. Defective components were identified and rejected before they could be fitted to operational aircraft. Japan's attempts at turbocharger production yielded perhaps a few dozen units per month, with reliability so poor that most failed after only a few hours of operation. By August 1944, Japanese intelligence had compiled deeply concerning reports regarding the capabilities of American bombers. Interrogations of captured B-29 crewmen, analysis of wreckage, and observations from pilots painted a picture of technological superiority that profoundly shocked military leaders. The B-29 was not merely a large bomber. It was a sophisticated aerial weapon system incorporating innovations that Japan could not replicate. Colonel Takushiro Hattori, an operations officer at Imperial General Headquarters, recorded his thoughts in his diary that month regarding the implications of the B-29 raids. He noted that American bombers operated with impunity at altitudes that Japanese fighters could not effectively contest. The few interceptors that managed to engage reported that even when they scored hits, the B-29's robust construction absorbed damage that would have destroyed Japanese aircraft. The most alarming realization was that these raids represented merely the beginning. American production capacity suggested that thousands of B-29s would eventually be deployed against Japan, each one operating beyond the effective reach of Japanese defenses. The fundamental mathematics of aerial interception had shifted catastrophically against Japan. A fighter climbing from ground level to 30,000 feet would consume approximately 30 minutes and burn 1/3 of its fuel load. At such extreme altitudes, fighter performance degraded dramatically. Their guns, while deadly at close range, required pilots to maneuver within a few hundred feet of their targets, a feat made nearly impossible by the reduced performance of their aircraft and the B-29's advanced defensive fire control systems. Even successful interceptions often came at the cost of irreplaceable, experienced pilots who perished when damaged or fuel-depleted fighters crashed during their attempts to return from extreme altitudes. Major Makoto Ogawa, who would eventually claim 7 B-29 kills, becoming one of Japan's most successful Superfortress hunters, later described the overwhelming disadvantage faced by Japanese pilots. He stated that American bombers flew in an aerial realm where Japanese aircraft could barely function. While Americans benefited from pressurized cabins and heated compartments, Japanese pilots endured temperatures 40 degrees below Fahrenheit at high altitudes, their fingers numb despite electrically heated flight suits that rarely operated correctly. Oxygen systems frequently malfunctioned, leaving pilots hypoxic and disoriented. Their gun barrels froze, ammunition belts jammed in the cold, and their engines ran so roughly that pilots lived in constant fear of flameouts. Japanese aircraft designers desperately sought solutions. The Nakajima Ki-87, developed specifically as a high-altitude B-29 interceptor, incorporated a turbo-supercharged Nakajima Ha-219 engine, designed to provide effective performance above 30,000 feet. On paper, the design was impressive, boasting a service ceiling above 40,000 feet, formidable armament including 30mm and 20mm cannon, and sufficient speed to overtake B-29 formations. However, only one prototype managed to fly before the war's end in April 1945, revealing severe operational problems. The turbocharger, crudely assembled from inadequate materials with insufficient testing, failed repeatedly. Even when it functioned, its performance was inconsistent. The project ultimately faltered, not from a lack of engineering talent, but from an insufficient industrial capacity to produce reliable turbochargers. The Tachikawa Ki-94, another proposed high-altitude interceptor, never progressed beyond the mock-up stage. The Mitsubishi J-8M, a rocket-powered interceptor based on the German Me-163 Comet, offered high-altitude capabilities without turbochargers, but its volatile rocket fuel and extremely short endurance rendered it impractical for defending against sustained B-29 raids. Japan's most skilled aeronautical engineers understood what was required, but lacked the fundamental industrial infrastructure to produce it. American B-29 operations expanded relentlessly. By November 1944, the 21st Bomber Command commenced missions from the newly established bases on Saipan, Tinian, and Guam. These islands were situated a mere 1,500 miles from Tokyo, well within the operational range of the B-29. Lieutenant Colonel Robert K. Morgan's mission on November the 24th dispatched 111 Superfortresses against the Musashino aircraft engine plant in Tokyo. While weather conditions and jet stream winds limited the mission's immediate results, the psychological impact on Japan was profound. American bombers now struck the Japanese homeland with increasing frequency, and Japanese defenses proved progressively ineffectual. Sergeant Shoi Suzuki, an anti-aircraft gunner stationed near Tokyo, maintained a diary that chronicled the growing despair among the defenders. Initially, his unit engaged B-29 formations with a degree of confidence, their 75mm guns firing shells to altitudes of around 25,000 feet. However, the American bombers frequently flew higher, beyond the effective range of the guns, or approached at angles that provided the gunners with insufficient tracking time. More frustratingly, even direct hits rarely succeeded in bringing down a B-29. The bomber's robust structure, incorporating redundant systems and armored critical areas, could withstand damage that would have utterly disintegrated Japanese aircraft. Suzuki recorded instances of watching crippled B-29s, trailing smoke with engines shut down, continue their course towards their targets and often return safely to base. Japanese efforts to enhance air defenses primarily focused on modifying fighter performance. The Kawasaki Ki-61 Hien, powered by a liquid-cooled Ha-40 engine, could reach altitudes of approximately 32,000 feet, higher than most Japanese fighters. However, its climb rate was insufficient, and engine reliability was so poor that many Ki-61 aircraft were grounded awaiting spare parts. The Nakajima Ki-84 Hayate, introduced in 1944, represented Japan's most advanced mass-produced fighter. It featured the Nakajima Homare engine, a complex radial design that delivered good performance at altitude when meticulously maintained. Unfortunately, the Homare's intricate construction demanded extensive maintenance, and quality control issues resulted in premature engine failures. The Ki-84's theoretical performance was impressive, a maximum speed of around 400 miles per hour at 20,000 feet, a service ceiling near 35,000 feet, and a heavy armament of 20mm and 30mm cannon. In practical application, few Ki-84 aircraft achieved these specifications. Poor quality fuel-damaged engines, crude lubricants failed to perform at low temperatures, and manufacturing defects led to frequent operational failures. American pilots who test flew captured Ki-84 aircraft after the war praised their handling and performance, noting that they matched or exceeded American fighters in some aspects. However, they also observed that these captured examples had been meticulously selected for their exceptional condition, maintained by skilled Japanese mechanics using hoarded, high-quality materials. The average operational Ki-84 performed significantly below its design specifications. Even when Japanese fighters managed to reach the B-29's operational altitudes, they were confronted by the bomber's sophisticated defensive armament. Each Superfortress was equipped with 10 50-caliber machine guns mounted in remotely controlled turrets. A centralized fire control system allowed gunners to coordinate their fire, concentrating the power of multiple turrets on single targets. This system incorporated computing sites that automatically calculated lead and deflection, thereby significantly improving the probability of a hit. Japanese pilots quickly learned that approaching within effective gun range of a B-29 formation meant flying through coordinated barrages, from which few emerged unscathed. The psychological impact on Japanese pilots was devastating. They had been indoctrinated to believe in the superiority of Japanese aviation and the invincibility of the Bushido spirit over material advantages. The reality of combat against the B-29s shattered these deeply ingrained illusions. Captain Yasuhiko Kuroya, a veteran fighter pilot with the 302nd Air Group, wrote in a letter discovered after the war that engaging B-29s felt akin to attacking a fortress. The bombers absorbed punishment that would have destroyed a dozen Japanese aircraft, their crews protected by armor and redundant systems, while Japanese pilots flew unarmored fighters with vulnerable fuel tanks and minimal protection. December 1944 brought the first major daylight raid against Tokyo, with 86 B-29s targeting the Musashino plant. Japanese defenses managed to shoot down or damage several bombers, but at a terrible cost. The 244th Sentai, led by Captain Kobayashi, claimed the destruction of 6 B-29s through desperate ramming attacks, but lost multiple irreplaceable pilots in the process. Ramming became an increasingly common tactic as Japanese pilots realized that conventional attacks often failed to bring down the massive bombers. This tactic was, in essence, suicidal. Pilots would aim their fighters at the B-29's wing roots or tail assemblies, hoping to disable its control surfaces, and then attempt to bail out before impact. Few survived. American crews, while horrified by the waste of life, respected the fanatical courage of these Japanese pilots. Technical Sergeant John McLaughlin, a gunner aboard the City of Los Angeles, later recounted witnessing a Japanese fighter deliberately ram the B-29 flying alongside his. The fighter struck the bomber's tail, shearing off the entire vertical stabilizer. Both aircraft spiraled out of formation in uncontrolled dives. McLaughlin saw no parachutes. He later learned that the B-29 crew, all 10 men aboard, perished in the crash. The identity of the Japanese pilot was never known, one of thousands who died defending their homeland against an enemy they could not overcome. By early 1945, Japanese air defenses had deteriorated to the brink of collapse. Fuel shortages grounded many fighter squadrons. Experienced pilots had been lost in staggering numbers, replaced by teenagers with minimal training who stood little chance against seasoned B-29 crews. The addition of American fighter escorts, P-51 Mustangs flying from Iwo Jima following its capture in March 1945, rendered the defense against B-29 raids even more hopeless. Japanese interceptors, climbing sluggishly to altitude, became easy targets for the P-50s, which could outclimb, outrun, and outfight any Japanese fighter. The night of March 9th to 10th, 1945, marked the single worst catastrophe in Japanese history. General Curtis LeMay, commanding the 21st Bomber Command, ordered a radical shift in tactics. Instead of precision bombing from high altitudes, 334 B-29s would attack Tokyo at night from altitudes around 7,000 feet, carrying incendiary bombs specifically designed to ignite widespread fires. This decision was met with controversy as the lower altitude exposed the bombers to more intense anti-aircraft fire. However, LeMay calculated correctly that Japanese night defenses were relatively weak, and the lower altitude eliminated the stress on the turbochargers, engine overheating issues, and allowed each B-29 to carry a significantly larger bomb load. The results exceeded LeMay's expectations. In 3 hours, American bombers unleashed nearly 2,000 tons of incendiaries on Tokyo's densely populated districts. Devastating firestorms developed, creating hurricane-force winds that sucked oxygen from shelters and generated temperatures exceeding 1,800 degrees Fahrenheit. An estimated 100,000 people perished, a death toll greater than that of either atomic bombing that would later occur. 16 square miles of the city were reduced to ashes. Remarkably, only 14 B-29s were lost, an exceptionally low number given the intensity of the raid. The Tokyo firebombing demonstrated that even without fully exploiting their high-altitude capabilities, B-29s could inflict devastating damage upon Japan. However, the turbochargers had fundamentally made the B-29 force possible. Without the ability to operate at high altitudes, to fly above the weather, and to cruise beyond the reach of enemy fighters, the strategic bombing campaign would have been entirely unsustainable. Missions launched from China across vast distances to Kyushu absolutely required high-altitude efficiency. Daylight precision raids targeting aircraft factories and oil refineries demanded the protection that altitude provided. Even the low-level firebombing raids were only feasible because American air superiority had been decisively established through earlier high-altitude operations that crippled Japanese fighter production. Japanese engineers who meticulously examined captured B-29 components after the war expressed a profound, almost bitter admiration for American engineering prowess. The turbochargers represented everything that Japan's domestic industry lacked: Precision manufacturing, advanced materials, rigorous quality control, and the industrial capacity to produce thousands of complex units monthly. A single B-29 incorporated 8 turbochargers. American production exceeded 200 B-29s monthly by 1945, meaning 1,600 turbochargers were needed monthly just for new aircraft, in addition to thousands more for replacements and ongoing maintenance. General Electric's factories produced these vital components at a rate that Japan could not have possibly matched, even if its entire aircraft engine industry had been dedicated solely to turbocharger production. The broader implications were starkly clear to discerning Japanese observers. If America could produce turbochargers in such immense quantities, what other technological marvels could it produce? The answer became undeniably evident in the relentless waves of B-29s that appeared over Japan almost daily by the summer of 1945, in the P-51 escorts that effortlessly destroyed Japanese fighters, in the naval forces that imposed a complete blockade on Japan, and finally, in the atomic bombs that fell upon Hiroshima and Nagasaki. First Lieutenant Toshio Oht, a technical intelligence officer who survived the war, later wrote that examining captured American aviation technology induced a profound sense of despair among Japanese engineers. He observed that every system, every component, demonstrated manufacturing quality and engineering sophistication that far surpassed Japanese capabilities. The engineering marvel of turbochargers particularly captivated him, as their operational principle was elegantly straightforward, yet their implementation demanded a level of meticulousness that Japan's war-ravaged industrial sector could no longer achieve. Even if Japan had, by some extraordinary means, acquired turbocharger schematics in 1941, he concluded that the nation simply lacked the fundamental industrial infrastructure to manufacture them in any meaningful quantity. The human toll exacted by this technological disparity was immense. Japanese aviator training programs, once renowned for their stringency and the exceptional caliber of the pilots they produced, had by 1945 completely disintegrated. Due to severe fuel scarcities, aspiring pilots were fortunate to receive approximately 50 hours of flight instruction, a stark contrast to the 200 to 300 hours afforded to their American counterparts. These inadequately prepared aviators were subsequently tasked with engaging in combat, using outdated aircraft against adversaries who possessed every conceivable advantage. During a significant engagement over the inland sea in July of 1945, Japanese fighter planes launched an assault on a formation of over 100 B-29 bombers. According to American records, a mere 2 bombers sustained damage, whereas the Japanese forces incurred the loss of 23 fighters destroyed, with negligible impact inflicted upon the bombers. The relentless bombing campaign by the B-29s ultimately deposited 147,000 tons of ordnance onto Japanese territories, obliterating 40% of urban industrial zones across 66 cities and resulting in the tragic deaths of an estimated 330,000 civilians. Japanese war production, already in a state of decline, utterly collapsed by the summer of 1945. The nation's transportation networks had been systematically destroyed, rendering the movement of vital resources impossible, even where they might have existed. Factory workers, fleeing the conflagrations engulfing their cities, abandoned their posts. The government found itself unable to exert control over economic planning as industries either relocated to rural areas or ceased operations entirely. Major General Aris Suer Seizo, who held the position of Chief of Japanese Military Intelligence, candidly admitted in the aftermath of the war that by June of 1945, his intelligence analysts had recognized the inevitability of defeat. American air supremacy was absolute. The B-29 campaign had effectively crippled Japan's capacity to sustain warfare. Nevertheless, the Japanese government, bound by a rigid military code of honor that prescribed surrender, continued the struggle until the deployment of atomic bombs provided a justifiable rationale for capitulation. The atomic bombings of Hiroshima on August 6th and Nagasaki on August 9th, 1945, marked the definitive conclusion of the Second World War. These devastating atomic weapons were delivered by B-29 aircraft, whose ability to reach their intended targets within Japan and return safely was fundamentally reliant on the sophisticated technology of turbo-superchargers. The Enola Gay, soaring at 31,000 feet above Hiroshima, operated at an altitude made possible by 8 General Electric turbochargers that maintained engine performance in the attenuated atmosphere. Even at the war's conclusion, with Japanese air defenses rendered largely non-existent, the altitude capability afforded by turbochargers provided a critical layer of protection against any residual anti-aircraft fire and allowed the crews to escape the devastating effects of the atomic detonations. Post-war interviews with Japanese fighter pilots consistently revealed a sentiment of admiration mingled with profound frustration. They held American engineering in high regard and acknowledged that no degree of pilot proficiency could surmount such a profound technological deficit. Lieutenant Isamu Sasaki, a survivor of the war with a remarkable record of 3 B-29 kills, one of the highest tallies achieved, later reflected that his successes were solely attributable to perfect circumstances. Surprise attacks from above, with the sun at his back, against isolated bombers separated from their formations. Against formations flying at high altitudes with vigilant crews, even the most skilled Japanese pilots rarely achieved victory. The pursuit of high-altitude aviation capabilities had been a long-standing endeavor for numerous nations prior to the Second World War. Germany had indeed developed turbo-superchargers but never successfully integrated them into operational use, instead prioritizing the development of mechanical superchargers, which, while simpler, exhibited diminished efficiency at extreme altitudes. Britain, for its part, primarily relied on highly advanced multi-stage mechanical superchargers, which delivered commendable high-altitude performance without the inherent complexities of turbocharging. America alone adopted turbo-supercharging as standard equipment for its heavy bombers, accepting the attendant increases in complexity, cost, and maintenance requirements in exchange for unparalleled high-altitude performance. This strategic decision underscored a profound confidence in American industrial prowess. Turbo-superchargers necessitated precision manufacturing processes, regular servicing by highly skilled technicians, and a dependable supply chain for replacement parts. America possessed the robust infrastructure to fulfill these demanding requirements. Japan, conversely, did not. Even if Japanese engineers had conceived of perfect turbochargers in 1941, the nation lacked the manufacturing base to produce them in sufficient volumes, the organizational capacity to maintain them in operational condition, and the logistical system to provide the essential spare parts and replacement units. The United States Strategic Bombing Survey, conducted in the post-war era, concluded that the B-29 campaign had been a decisive factor in eradicating Japan's capacity to wage war. While the survey's authors debated the precise point at which Japan might have surrendered without the atomic bombings or the planned invasion, they were unanimous in their assessment that by August of 1945, American air superiority was absolute and Japanese defenses lay in ruins. The technological advantages possessed by the B-29, particularly its high-altitude capabilities facilitated by turbo-superchargers, rendered this outcome an inevitability once a sufficient number of these bombers became operational. Japanese military records, seized in the post-war period, illuminated the extent to which B-29 raids dominated military planning from late 1944 onwards. The Imperial General Headquarters committed vast resources to air defense, diverting fighter units from other combat zones, constructing thousands of anti-aircraft emplacements, and training tens of thousands of troops for the defense of airfields. However, all these efforts proved utterly ineffectual against bombers operating beyond the reach of effective defensive measures. The final B-29 mission against Japan took place on August 14, 1945, the day before the official announcement of surrender. More than 300 superfortresses targeted installations near Tokyo, encountering absolutely no resistance. Japanese fighter planes remained grounded, conserving precious fuel for the anticipated American invasion that would never materialize. The B-29 crews returned to their bases in Marana, unaware that the war had essentially concluded. Their missions had been successfully accomplished through the cumulative destructive power of hundreds of raids that Japan was utterly incapable of preventing or effectively countering. In the decades following the war, aviation historians and aeronautical engineers undertook extensive analyses of the B-29's technological advantages. The prevailing consensus was unequivocal. Turbo-supercharging provided the fundamental capability that enabled the strategic bombing of Japan from distant bases. Without this technology, the operational ceiling of the B-29s would have been restricted to altitudes of approximately 20,000 feet, well within the engagement range of Japanese fighters and anti-aircraft artillery. Such losses would have been unsustainable, rendering the entire strategic concept of bombing Japan from the Mariana Islands bases entirely impractical. The lessons learned by Japanese engineers through their examination of American aviation technology profoundly influenced post-war Japanese industrial development. The emphasis on precision manufacturing, rigorous quality control, and systematic engineering, which characterized the American production of turbo-superchargers, subsequently became defining features of Japan's remarkable post-war economic resurgence. Former aviation engineers transitioned into civilian industries, bringing with them a hard-won understanding of advanced manufacturing techniques. The Boeing B-29 Superfortress flew its last combat sortie in 1954 during the Korean War. By that time, jet-powered bombers were increasingly supplanting propeller-driven aircraft, and turbo-supercharging for piston engines had become an obsolete technology. However, the enduring legacy of the B-29 persisted. It unequivocally demonstrated that technological superiority could overcome numerical inferiority, that industrial capacity was as crucial as individual valor, and that air power, acting in isolation, could indeed cripple a nation's ability to wage war. Today, only 2 B-29 aircraft remain airworthy, meticulously preserved and maintained by dedicated organizations, ensuring that future generations will have the opportunity to witness these historically significant machines. When these formidable bombers take to the skies at air shows, their magnificent R-3350 engines emitting that distinctive deep-throated roar, few spectators realize that concealed within their engine nacelles are the turbo-superchargers, the silent survivors of a technology that played a pivotal role in concluding history's most destructive conflict. These components, spinning at thousands of revolutions per minute as the B-29s ascended towards their operational altitudes, continue to perform the function for which they were engineered 8 decades ago. Compressing air to sustain engine power in the rarefied atmosphere. The narrative of Japanese forces confronting the B-29 Superfortresses ultimately serves as a powerful testament to how industrial capability and technological advancement fundamentally determine the outcomes of modern warfare. The turbo-superchargers that enabled the B-29s to operate at altitudes of 30,000 feet. The industrial ecosystem that produced thousands of these intricate components. The training regimens that prepared air crews for their effective utilization, the logistical support system that ensured their continued functionality. These were the true instruments of the strategic bombing campaign. The technological ascendancy of the B-29 did not guarantee American victories from the outset of hostilities. However, once American industry fully mobilized, once B-29 production reached its peak capacity, and once the air bases in Marana became fully operational, defeat for Japan became an inescapable certainty. No amount of pilot skill, no degree of personal sacrifice could possibly surmount the material and technological advantages embodied in those gleaming silver bombers that droned overhead at altitudes where Japanese fighters struggled for breath. As the B-29s cruised at 30,000 feet above Japan, their turbochargers silently spinning within their engine compartments, maintaining sea-level power in the stratospheric air, they carried far more than mere bombs. They carried irrefutable proof that industrial might had ascended to become the decisive determinant in modern warfare, and that America possessed this might in quantities that no adversary could possibly match. Japan had never anticipated such a grim reality. And once the silver behemoths filled the skies over the home islands, operating with impunity beyond the reach of any effective defense, There was absolutely nothing Japan could do to halt their advance.